Hey, what's going on? I think I'm live right now. Let's go ahead and jump into today's let's go ahead and jump into today's programming. Hello everybody. My name is Paul Chin Jr. and I'm from Serverless Guru, and today we're doing a webinar for our 2025 Spring Hackathon. This is super exciting. We've been doing this for the last couple of years, and it's such a wonderful opportunity to bring the community together, bring nice technical moments from everybody. And this year's theme is EDA, event-driven architectures, kind of like the big buzzword for all things serverless. If you're new to the hackathon, welcome. There is still plenty of time for you to sign up at hackathon.serverless.guru. Go ahead and sign up because we do have cash money prizes, and more importantly, the opportunity to learn all about serverless architectures and event-driven architectures. If you want to go ahead and sign up, the hackathon is running until the 18th, and it just started a couple days ago, so plenty of time. The other thing, if you are just now joining us, is be sure to sign up for the Discord. We have a Believe in Serverless Discord where all of the community is coming together. There's a wonderful question answer sections. People are getting tons of help. People are throwing out ideas. I believe it's the best part of the hackathon, right? To give everybody a chance to come together and actually figure out how to deploy these kinds of things. And today's session and all the previous sessions and sessions going forward are going to be recorded and put onto a public playlist on the Serverless Gurus YouTube channel. So if you're watching right now live, thank you so much. We do have chat available, so if you have questions, drop them in the chat no matter what platform you're on. I'll be watching them all. And then if you are not able to watch this right now live, then the recording will be up on our YouTube channel. So definitely check that out as well. Let's see what else. Coming up May the 9th at 10 a.m. Pacific time, 1 p.m. Eastern, United States time, we're going to have another presentation webinar with Jones Zachariah Noel N. And he's going to be talking about why observability matters in EDA applications. And then on May 16th, we'll have Alan Helton presenting his talk, Pushing Messages and Limits, with Memento. And Memento is another great sponsor of this hackathon, so be sure to check out Memento and all that they have to offer. And we thank them again for sponsoring and helping to produce this wonderful hackathon this year. Okay, let's see. Now with the announcements out of the way, I think we're ready to go on to our main event today. I have the distinct pleasure of introducing my good friend Sandro. He is a full stack developer, and when I say full stack, I mean full stack. We go beyond containers. We go beyond the application layer. We're talking about actual back-end deployments as well as front-end assets and everything. So let's bring him to the stage. Sandro, how's it going, my friend?
Hey, Paul. I'm very good. How are you?
Very good. Very good. Awesome. Well, thanks again for coming on to share with us the Believe in Serverless folks and being a part of being a resource in this wonderful hackathon that we've got going on. Let me go
Absolutely
ahead
the
and
worst.
bring up your presentations. Oh,
Yeah.
add to stage right there. Very good. And then, I'm clicking too many buttons. Well, all right, folks. Here is Sandro. He's going to start taking it away. And again, if you have any questions, drop them in chat. I'll be following along. And from here on, Sandro, take it away, my friend.
That's great, Paul. Thanks a lot. So, hey, everybody. My name is Sandro Volpicella, and in the next 40 minutes or so, I will talk to you about event-driven architectures. I think, like Paul said, that's the theme of the whole hackathon. So I love to see talks like Jones's talk as well, because that's definitely an important thing to have observability in there as well. But today I will talk about EDA for the real world, and I gave the presentation this title because I don't only want to talk about the theory of why we need event-driven architectures, what the goals are, and so on and so forth, which is also a small part of that. But I really want to show you hands-on examples how I implement EDA, how I do it in a serverless way on AWS, and especially with hands-on TypeScript, CDK, and code examples. So first of all, who am I? Like Paul already said, I'm a full stack software engineer. I am specialized in AWS and serverless, but since forever, I'm already working with front-end technologies as well, especially Next.js, Remix, and now as I give 10stack start as well. And I live in Munich, in Germany. And for the past 3-4 years, I worked freelance at Hashnode. So I've built up the whole event-driven architecture there, and I've built the first line of code there also for the whole AWS environment, which was quite interesting because Hashnode is a content blogging platform, and they have quite a scale. So we started with literally 0 events, and then I scaled it up, or we scaled it up until 1 million events a month. And you have quite some learnings in there and quite some best practices about developer workflows. So this is what I want to show you today. I'm also part of the AWS Community Builder program, which is quite a nice program in case you want to meet like-minded people and creators. This is definitely a good place to be in. And since I really like to share my learnings, as you can see here, I also authored 2 books with a good friend, AWS Fundamentals and the CloudWatch book. The first one focuses a lot on best practices, how to reuse basically the same services to build anything. And the CloudWatch book obviously focuses on CloudWatch and all their features. So let's dive into today's agenda. So I have a twofold agenda here. First of all, we focus a bit on theory and architecture. I've labeled the whole talk on level 300 on the AWS scale of levels. So I have some prerequisites about AWS services, so I don't want to introduce everything from the bottom. And after the theory and architecture, I want to go more into hands-on and especially TypeScript examples to show you how to validate events, have errors, archives, idempotency, and all of that good stuff. And as an example application, of course, like I said, I did this with Hashnode in the past couple of years. So I have a blogging platform as an example, which will be used throughout the whole presentation. So a blogging platform, basically something like Hashnode, Medium, or DevTO. So you can imagine something that you can create a blog, people can sign up, people can read blogs, and we can publish blogs. And especially the part of publishing the blog is the one part which will guide us through the whole presentation. So let's start with the obvious question, what actually event-driven architecture is. And I define it pretty simple. I simply say systems react to events instead of being told what to do. And I'll show this to you in a visualization in a second. And the technical goal of event-driven architectures is to decouple your system. So you want looser coupling of your system components. But it is not only about a technical goal. We also want to understand, if I do such a project, what is the real world goal? So what do I benefit from that? And this is on the one part feature velocity. And this is it was something I really saw working in the startup is your developers are just much, much faster building features if you have a decoupled system. And it is the typical things like resiliency and reliability. If your system goes down, if you have an incident and you have more decoupled components, then it's much easier to become your system healthy again. But let's go back to the point to system react to events instead of being told what to do. And how you typically start out in the way of building your CRUD APIs and your system is in a function-driven way. So you start out, you have somebody calling an API. In that case, you have a create post API. And this API orchestrates the other functions. And in this case, the API says, okay, you need to do X, Y, Z. What we want to have with event-driven architecture is to decouple these things and say that the create post API simply puts something on an external component. In this case, I've already put an EventBridge and says, hey, I just published a post. I don't care what you do next. I did my thing, you do your thing. And why we are doing this, we will see in a second. So like I said, we get started. We have a typical synchronous API, create post, which is a synchronous request. That means this is a blocking request. So I click publish post, loading indicator appears, and we wait. So the user is blocked. And first of all, we start out, we have a publish post functionality, exactly what the API should do. But then there comes another functionality, like I want to calculate analytics. How many words has the user written? And then product manager comes along with great ideas, like we want to have a backup to GitHub. So we want to back up the post. And then new idea, we want to send a newsletter as well. And all of that lives now in the create post API, which is quite a lot. And there are some issues with that. And the first issue is timing. Like I said, this is a synchronous request. So that means the user is blocked until all of that is finished. And now the API, the publishing post, is maybe not even the slowest thing anymore because other things depend on that. You often need database IDs, for example. So we wait for publish post, then we can do some things in parallel, but still the slowest functionality here dictates how long the whole API takes. And that's not a great user performance and not a great user experience as well. And the second issue is error handling. If you think about it, the main thing we want to do is publishing a post. So let's say publish post is green, everything works, great. Calculating analytics as well, but then backup post in GitHub doesn't work anymore. For example, the access token was revoked. What are we doing now? Are we retrying the backup post? Are we just letting it fail and get an alert somehow? What happens with send newsletter? Is send newsletter allowed to be published if the backup fails? So what are we doing? So all of that just shows that having many responsibilities here, which is also a main software principle, is not a good way to do things. So we want to decouple that. So I just want you to keep in mind this picture, and this is also what we always remembered ourselves of, is in event-driven, I simply want the API, the event emitter, in that case, the publisher, want to say, hey, I publish something, I don't care about the consumer, I just tell some external component what I did. So this is what EDA is about. So now I could create our own 45 minutes talk on how to do EDA on AWS, but we just look at these three services now, which is SQS, SNS, and EventBridge. And I won't go too much into detail here, but let's compare these three. And one thing I want to say is also event-driven architecture is not just with EventBridge because the name event is in there. So everything you do basically in a serverless way is kind of event-driven architecture because you invoke a Lambda with an event, you invoke SNS or SQS with an event. So all of that is a type of event-driven architecture, but I would suggest comparing these like I do now, if you are in a greenfield project and really want to have a good event-driven architecture. So let's jump into that. First of all, SQS. SQS is simple queuing service. A simple queue service that simply means we store messages in a message queue and there's an external consumer like a Lambda function polling these messages. In our case, we have a GitHub queue. The create post API sends this message to the queue. Lambda is processing it. What is really good here, it's already asynchronous. That means our whole timing issue is gone. What's also good is that the error handling is now not on the consumer or not on the create post API anymore, but it is on the consumer and on the SQS queue. But what is still bad is we need one queue for one task. That means the create post API still needs to understand there is such a feature like GitHub backup, and there are other features. And if you follow typical SQS best practices, then you have one queue for one task. So that means you have multiple queues, and you always need to touch the API again just to create another feature. That's not great. So, and this is also the whole coupling part. We're still coupled between the API and the queue. So SQS is not good. Let's now look at SNS. SNS is the simple notification service. It's especially meant for high throughput messages. So we have an API sending something to an SNS topic. That's already very good. And the topic fans out the message to many consumers. In that case, Lambda, SQS is an example. And here we are almost there, to be honest. So we have coupling is good. So we are more loosely coupled. Our producer and our consumers are decoupled. That means the producer doesn't need to know anything about the Lambda function and the GitHub backup feature. And we have the pub sub mechanism that we actually want. So consumers can go in there and subscribe to our topic, and that's it. The bad part is still, and this is already compared with EventBridge, of course, we route via filtering. And in EventBridge, we have a pretty nice routing logic and routing mechanism. In SNS, we need to use filter policies on the consumer, and we can do them on the whole message, which is new since 2 years, I think, and on the metadata. But it's still not really meant for that in my perspective. And archiving your events is pretty normal that you do that. We see this later on. So saving all events and replaying them is not really given with SNS. So you really need to do this manually with Kinesis, S3, and so on. So this brings us to EventBridge. And this is why I want to show you EventBridge for a second. So in EventBridge, we have an architecture which looks like this. And basically, we decouple our architecture by introducing some more components. And these components here are an event bus. So each AWS account comes with an event bus. So we have a default event bus. We have custom event buses. I would always recommend creating a custom event bus for your application. And then we even have partner event buses. And this is pretty nice. For example, if you use Stripe, Shopify, or MongoDB, you can simply, or many others, you can simply, instead of having webhooks, simply have them here in your partner event bus. And I have a side project for Shopify, so I have a Shopify app, and like all of these, instead of handling like lots of orders via webhooks and having all of the API stuff, secret handling, signature handling, we just get them in our event bus, and that works out super nicely, and we can just plug in consumers as you want. Then the second component we add is an event rule. So the rule defines which consumers get the messages and if any consumer gets the message. For example, we subscribe to an event like create post, and then we can have additional logic, like if some Boolean values are enabled, if some numbers are activated, so something like that. And then we have targets, and targets are lots of services. So here in that case, I have SQS, Lambda, and SNS, just as an example. You can also have external APIs. You can have lots of other stuff. So this is basically what EventBridge is. Now we come to the first architecture part, and the first architecture is about the event envelope. And this is now the first time we see how an event actually looks like. So you can see this is a typical AWS event. We have a version, ID, account, all of that stuff. And what we care about is only the detail type. This is what the event is, so post published, and the detail. And the detail is the event you sent. So these are typically the only two things, maybe except for the source, you are touching for every event. And if I talk about an envelope, I only talk about detail. And the envelope defines how this detail block, how this JSON object looks like. And why are we even caring about that? So first of all, we have idempotency. If you worked with AWS before, you know that you always get multiple messages and you need to have idempotent operations. So, and for that, we often needed one unique identifier. This is where an event envelope helps a lot. Then we have versioning. Versioning your event schema is not super straightforward. There are many edge cases, but an event envelope will help you with that. And then observability. I hope Jones talks a lot about that. So you want to trace events through your system. You can imagine if you have one event emitting another event and so on and so forth, it can get quite complicated. And for that, you need one common identifier, also one correlation ID that you can trace through your system. So which approaches do we have? First of all, we can use metadata and data. This is what I always used in the past and still use because it's pretty simple. And the second one is cloud events, which we see in a second. So metadata and data. Metadata is an object within our event, so within the detail, just some common fields that are the same across all events. That means typically an ID. So I just add a UUID or some API request ID. We have a user. This can also be an object. Here I just have a user ID and typically a timestamp. Then the green block here is the data. So this is actually what is unique across your event. So this is different for post published versus post removed. In that case, we have a post ID and a block, and that's it. And cloud events, so if you go on Cloud Events.io, is a standard from the CNCF, so the Cloud Native Community Federation. And this defines something similar, I would say. So we have some required fields like ID, source, and type, and some optional fields, which is typically also data, time, and correlation IDs. You see that the required fields are also already existing in the event, in the AWS event itself. But still, if you think about sending this event to other custom event buses, for example, to other Kafka topics, to something like that, then it makes sense to have like a standard everybody agreed on, which is cloud events. And there's also quite a cool blog post from David Boyne, how you can transform your event with EventBridge pipes into a cloud event specification. And you have SDKs and you have all of that stuff in cloud events. But if you just get started, if you have a smaller project, I would say just go with metadata and data, and that's it. So the second part of architecture, what I always recommend doing and thinking about is the pattern of how you design your rules. And this is called the subscription pattern here. So there's one misunderstood limitation in EventBridge. I think this is the most misunderstood rule probably in AWS, which is targets per rule. And that defines how many targets, so consumers of events, can you have per rule. This is defined as 5, and there's no way to upper this limit. And there's even a YouTube video that compares basically the same thing I did, SQS, SNS, EventBridge. And it is the #1 YouTube video you can see if you look for this comparison. And even the subtitle here says that the fact for a specific rule you can have a maximum of 5 targets, he doesn't recommend using EventBridge. It's quite old, this video, and like the first comment is from an EventBridge PM who says, hey, this is not how you design them. So this is why I want to show you how you actually design your rules. Targets per rule. So how it typically looks like, we have an event bus. We have a rule which matches or not matches all of the incoming events. And then in the orange box, we have targets. And the rule defines that we have 1 rule and 5 targets. So as you can see here. Now we have the event rule post published. So every event that comes in with the detail type post published will be sent to all of these 3 targets. But the newsletter actually is also defined in the event on the blog, basically in the blog settings, that says, is the newsletter even enabled? Because we don't need to send it to this Lambda function and incur costs, just for every event, for every post-published event. So we could do one thing, we change the rule. But of course, what happens now is that all of the others, so the analytics Lambda, the GitHub backup Lambda, also don't get the event anymore for every event, only for newsletter enabled. So what we do next now, what we typically would do next is group them. So we group the 2 analytics Lambda and GitHub back Lambda with 1 event rule and the newsletter Lambda with the other one. And this is actually where this thought comes from. So what if you not only group them smartly, because to be honest, it's not easy to think about the groups, but to have 1 rule per subscriber per rule. So this is called the subscription pattern, and this is what I would always do. So I would always say have 1 rule for 1 subscriber, and they are not allowed to have more targets, more subscribers than 1. And why we are doing this is because with having the other setup, so this setup here, we introduced coupling again. We have coupling now on the event rule. The event rule decides who will get the event. And even as a new target, as a new consumer who's super independent of all of the other stuff, he now needs to decide, he now needs to touch the event rule for others as well and maybe break them. And this just requires more communication and more basically things that can break. So I would say always go with a subscription pattern, have your subscriber, the responsible ones, they should be able to just subscribe, and that's it. And how I typically do this, so I use CDK a lot, and how I typically do this is by having a custom construct here. So we have the EventBridge subscription construct. This one is for guard duty, so I give in an event pattern with the source guard duty and a Lambda target. And I use Lambda targets a lot, which you see in a sec. And then you have this event rule, which has a dead letter queue attached and the target attached. And this ensures that developers are only allowed to use this. They're not allowed to import AWS events and create their own pattern and multiple rules. They can only use this. And especially as a platform team, for example, I suggest that you create these kind of constructs and give your developers just the freedom to use them, and you set the best practices. So much for like the theory and architecture agenda. Now we go into the hands-on agenda. So we talk about event validation, idempotency, error handling, and testing. And for all of that, we will use middlewares. So I just want to quickly introduce you to MIDI. which is one of my favorite frameworks, I would say, I use on a daily basis. And MIDI allows you to use reusable middlewares. And I think if you've used Express, for example, so back in the Node Express times, we used middlewares a lot. And this is, I think, where the concept comes from. So we build reusable things that we can use on our Lambda function. And MIDI has 3 phases. On the one side, we have the before phase, we have an error phase, and we have an after phase. So if you think about it, what should happen before the Lambda invocation starts, we often check the context. So we have the Lambda context. We set correlation IDs, and we validate the event. On errors, we often want to log the error because there's nothing more annoying that you have an error, but it's somewhere hidden in the report log without any correlation IDs. And then on the after handler, we do some more things, closing database connections and stuff like that. So I definitely suggest that you check this one out. I really like MIDI. And how the syntax of MIDI looks like is, as in here, we have MIDI. So we initiate the handler. This is simply the handler code we have. And then we have the .use. So it's always like this dot notation. So we have .use. I always have all of the EventBridge middlewares in like one combined middleware. And then here, just as an example, you also have a DB connection. So this is how you use MIDI. And this is what we use for the rest of the presentation now. For example, for validation. Validation is quite interesting topic. So we have a validation in that sense on 2 parts. First of all, the API handler sends something to the event bus. We need to ensure that the correct event will be sent here. This is the easy part. And then the event bus matches and somehow sends it to Lambda. And this is the bit more complicated part where we need to validate, is the actual correct event incoming into the Lambda function or something wrong coming. Let's look at the first part. So the API handler emits an event to EventBridge. And how I typically do this is we have event emitters. So in that case, we have imposed event emitter, .published, .updated, removed, and so on. And there we pass some data in. For example, we need a UUID. So we need a unique identifier, which is here the request ID, and then we pass in some more data which is required. This is simply a TypeScript type, so we always know what is required. So that's kind of the validation which we have. The next part is the actual interesting validation, which is EventBridge routing to the consumer, so to our asynchronous Lambda function. And to validate this, we need 3 different parts. First of all, we need the event. We know the event by now. So here we have a detail, metadata, data, and you can already see that we have a post and a blog. But then we need a schema. And for schemas, I always make use of the TypeScript library SOT, which is super nice. And here I have, for all of my events, I use a SOT schema. So one distinct SOT schema where I define how the event looks like. And I can see that I have metadata, so a metadata schema is always the same. And then we have data, which is defined here as post, which is an object with an ID string, blog, and so on and so forth. And I have all of these either in my monorepo in a package or in an NPM package, or if you use Python somewhere in your registry with Pydantic. And I export those and can consume them from my app. So in that case, from my CDK app, for example, from my Lambda functions. And then I can define here the event as the post-published event and my schema as the post-published event schema. So this is how I share all of my events. And the third part I need is a middleware. So this is now the first time you actually see a MIDI middleware function, so how it looks like. So in the validate event, this is a pretty simple middleware, which simply defines the before function. So that means it runs before the actual invocation starts in Lambda. And then we just get the correct schema because we can pass in a list of schemas. And then we just make a safe pass. So we pass it, we see if everything works out. If it doesn't work out, we log and throw an error. If it works out, we say, hey, cool, event matches schema, and continue and do nothing. So this is how simple validation can work out. But this can save you from lots and lots of trouble, especially lots of side effects. Because before we had this in place, we also did start without that. Before we had that in place, we had sometimes weird side effects where we did some kind of database operations and ended up in a weird state and we had no idea why. And in the end, just a wrong event was emitted and something was changed on the API. And if you read this, the event doesn't match the schema with the actual error, so that it's a number instead of a string, then you immediately know what the issue is. So I definitely recommend doing validation. And I also recommend that you handle your errors and retry them, like in distributed system you should. And especially on EventBridge, one thing, so this is a tweet of mine when I started working on EventBridge and mocking some errors finally. And I had the issue that I didn't know why my events never reach my dead letter queue, because I put in the Lambda, I throw a new error, and I had no idea why the freaking event never reached my dead letter queue. And this is because I simply didn't understand which kind of errors can happen in EventBridge. So there are kind of two things that can happen. We have server errors, or I also call them delivery errors, and we have consumer errors. And server errors are typically the errors that don't happen a lot, and consumer errors are typically these errors I wanted to handle, so the errors that happen a lot. On server errors, it means EventBridge gets the event, an event rule matches, but it can't be delivered to your target. I always use Lambda here as a target. So it can't be delivered to your target. And what can be the reason for that? The reason can be your IAM permission is missing. I would say that's 99% of the cases. Or Lambda API is down. I bet there are some other permissions, some other things as well, but these are the two main things. Lambda API is fortunately not so often down, so it's typically an IAM permission. And what you can do on these server errors is simply you can attach a dead letter queue to your event rule, and you define a retry mechanism, backoff rate, and all of that nice stuff into your event rule. So this dead letter queue lives on your event rule, not on the Lambda function. The event rule doesn't care if something happens on the Lambda function. How I'm doing this is the construct I've showed you earlier. We have the EventBridge subscription, and if there is a Lambda target, then we actually create a monitored dead letter queue. So simply a dead letter queue connected to our monitoring service. And then we add a target. And in the Lambda function, as you can see here, we have retry attempts and dead letter queue. Sorry, in the target Lambda function, we have these two things. And this basically defines how we handle our server errors. So this is something to have in place. Don't get me wrong, even if it doesn't happen that often, it can still happen. But the second part is much more important in my perspective, which are consumer errors. So it happens a lot that your Lambda function can't connect to your downstream system. So we used MongoDB with tons of issues with MongoDB. So this is the typical issue in my perspective. But for that, let's first understand what actually a synchronous Lambda versus an asynchronous Lambda is. Because if you use EventBridge, and I've now said tons of times that we use Lambda as a target, you don't call this Lambda in a synchronous fashion. And in a synchronous fashion, the receiver waits for the response. So this is the API example I had earlier with the loading indicator. And the caller controls the error handling then. So it is a blocking request. In an asynchronous fashion, it's more like a fire and forget. So EventBridge sends something to Lambda, it gets an acknowledge, and that's it. But it has no idea what happened next. So the consumer, in that case, the Lambda function handles the error. And the interesting part about asynchronous Lambda functions is that this is actually a hidden SQS queue with, or let's say a hidden queue with a Lambda function behind the Lambda API interface. So you have retries, you have destinations, you have lots of queuing. You also have like all of the throttling issues behind an event queue. It's just not that obvious as with an actual SQS queue. So asynchronous Lambda functions are a great thing. They give you lots of power, but you need to understand them. And just here an overview to understand which services are doing what. So in an API gateway, you call a Lambda function in a synchronous way. In an event source mapping with SQS as well. Step functions you can choose already. Lambda to Lambda you can choose as well. And DynamoDB and EventBridge, they're always asynchronous. And we talk about EventBridge here, so this is what matters. So EventBridge sends events to a Lambda function in an async way. And this is then how it looks like. So EventBridge sends the event, and you see the orange box. The orange box is Lambda now, actually. We have an event queue in the background, and the Lambda function pulls from this event queue. And the green and the red thing below that are destinations. So you can define an on success destination and say, okay, on success, I want to emit another event, which is a bit complicated, wouldn't do that. But on failure, I want to put it into an SQS queue, into a dead letter queue. And this is what we actually do. So this is how we received our alerts if something went wrong. And same thing, we have a CDK construct, Lambda with law group, it's always called. And the important part here is you see on failure, you can set in your Lambda function the prop on failure. And if it's called asynchronously, only then it works. It's a bit confusing in CDK. And then we have a new SQS destination, monitored letter queue, same thing as before, and retry attempts too. So we even can do 2 retries until we get this. And this saved us lots of struggles instead of having a queue it before and doing all of that manually. Asynchronous Lambda functions are really, really cool. And I think I've learned this even from Benoit from Serverless Guru. He showed it to me, and I really liked that approach. And this brings us to the next point, archive and replay. So in EventBridge, or first of all, let's start with the quote, which is kind of in almost every AWS community slide, which is everything fails all the time, which is a quote from Werner Vogel, so the CTO of Amazon. And if you've worked with AWS or with distributed systems ever, especially on a scale, you will see alerts and you will see percentages of weird error cases which you won't figure out. So you just need to have your mechanisms of replaying things and retrying things and error handling in place. So this is a quote which is just true. At some point you can improve lots of things, but at some point you really need to think about if it's worth it. So have your retries in place. And the cool thing with EventBridge, you can simply activate an archive. And here you see 2 rules. At the top, you see my rule, like blog, newsletters enabled, it goes to a consumer. And at the bottom, you see an archive rule. And the archive rule is created when you activate the prop on your event bus for archiving. Then you have a rule with an account name. So simply every event that comes in with your account number goes to an S3 bucket. And then the replay name is not allowed to exist. So because you don't want to replay events, so put them back on the event bus and have them again in the archive. So I definitely recommend that you activate this because you will need it, because you will have an incident. And how this then would look like for consumer errors is like that. So an event comes in, and first of all, the event is sent to the Lambda function. And if you say, okay, we have an issue now for MongoDB, like I said, happened a lot, then we didn't process the whole message. But at the same time, the event also was saved in an archive, in an S3 bucket. You don't have access to this S3 bucket. You only pay for the S3 bucket. That's basically the only cost you have with archiving. But you can't look at the JSON events. But what you can do is you can replay your events back on the event bus. So once we had this incident, we knew, for example, it was from about 10:10 to 10:20. So what we can initiate then is to say, hey, all of these events that came in that time, let's use them, put them back on the event bus, and let all consumer work on them again. Make sure that it's not too long and make sure your downstream systems can handle that. But that's another thing. But still, this is a great way. You can also enable that just certain rules can be activated, certain event buses and stuff like that. But that brings us to the question, of course, if you say 10:10 to 10:20, how do I know that this is the exact time frame? Maybe there are some duplicated events that I've worked on already. And this is where idempotency comes in. So idempotency helps you a lot that if we worked on an event, that we don't work on that again. So idempotency, I think in AWS documentation, you always read about at least once processing or exactly once processing. And at least once processing is the part we're talking here about. So if you look through Reddit, I looked for Reddit and idempotency and prevent consistently receiving duplicates and stuff like that. So everybody who starts working with AWS sees that there are many, many questions about exactly that topic. So why the hell do I get duplicate messages in my Lambda function? I don't want to have that. Where's the setting? And this is simply to the nature of distributed systems. Won't go into detail here, but you will need to handle these. And idempotency is just the number one skill you need to have working with serverless. I think James Eastham even has had like its own talk about that, and it's definitely worth it to look into that. So how I handle this is with MIDI middleware. So first of all, I have the post event emitter you saw earlier, and the request ID, which is a unique ID, goes into my metadata schema into the UUID. So this should show the flow of my middleware. So the API handler emits the event to EventBridge, and EventBridge sends it to the target. And actually, this is just the flow of the middleware, the right side. So the target tries to save the ID conditionally on DynamoDB. And DynamoDB either throws an error, which means so it was already executed, or success, so you can execute it. Let's have a look at that in a bit more detail. So this is the middleware now. We have a put item operation in DynamoDB. You can see in the put item operation, we have the input time to live, so TTL. That means we just want to save it for 24 hours. And a condition expression attribute not exists with this ID. We then save it on DynamoDB. If an error happens, then there are two things that can happen. If this is a conditional error because of this condition expression, then it is a success. So we return the event. For MIDI, that means we don't execute this event anymore, and we already executed the event. If another error happens, some other thing happens, probably IAM permission, and then we need to look at the error. But this is how we handle idempotency. And what I've learned from a great guy at AWS, so the team lead of the Power Tools TypeScript team, I think, is that this is actually not idempotency, it's deduplication, because in idempotency would mean the same result will happen again. And I only care about deduplication in that case. And I built this myself, so I think it's quite interesting to see how this worked, so how this works. But there are many, many more edge cases. For example, you can also have only small parts of your function idempotent. So if you do this by now, I definitely recommend you check out the framework Lambda Power Tools. They also make use of MIDI a lot. They just published their idempotency middleware or functionality, which is much more powerful than what you just saw. But the basic idea is the same. So check out that. And yeah, props to Andrea Amorosi to explain all of that stuff to me. And this is now how we can actually prevent the issue of having multiple messages if you replay it again. Because now we can simply say, hey, let's just execute it. I have no idea when the incident exactly was. Let's just execute it 5 minutes more. And if there were duplicate events, I don't care, because I simply need to call my idempotent function, so it deduplicates anyway. And this brings us to the last bigger part, which is testing. Probably the least favorite topic of many devs, but important topic. So I have kind of two tests here, or two type of tests, which is a unit test and an integration test. And I don't want to go into discussion here. So we defined the unit as something, and we defined the integration as something. And the unit here are our Lambda functions. So the Lambda function is either the API handler or my asynchronous Lambda function, so my target consumer. I only care about the consumer right now, so I look at the consumer as my whole unit. I personally not a huge fan of 100% test coverage, of mocking everything, or mocking way more than I do already, and testing every single bit. Especially when you work for a startup, you will see that you won't have the time for that. So I see my Lambda function as my whole unit. Since it's just simple Node.js code, you can just execute it like a typical script. You just need to mock two things. This is what I did here in the range block, is you need to mock the event, of course. And we mocked the database. So we have an in-memory shelf MongoDB database and seeded with some data. Then we call the Lambda function, and then we assert if the database has this result like I want it to have. For example, I assert if the newsletter in that case has some flag and some history entry. This is how I would recommend doing that. So I like that a lot, but you can also argue that it's an integration test. And I'm also fine with that because we have some integration with the database. But this brings us to integration tests. And integration tests, in that case, we have many integrations. We have the first integration, which is, does the event reaches the bus and then is forwarded to the target? Or the second integration would be from the target to other integrations, like with the database, like with other, if I want to invoke a step function, stuff like that. I only the tests for each consumer always if the event rule matches and goes to the target, because this is pretty simple to test. And I think follows the Pareto principle here very good. So how I did this is we had chest. I would now use vtest, but you can use chest for that. We emit an event to a deployed EventBridge event bus. So we have a development stage, put an EventBridge event on there, and the event had a UUID with a prefix test underscore, and with the flag is test true in the data. Then it was sent to the target, and surprise, surprise, we had another middleware here called handle test run, and this middleware is now printing the log to CloudWatch, checking if the flag is test is there and if it's true. If yes, we return the event. So we don't want to execute any test events. And then we simply continue. If not, we continue. And Chest is waiting the whole time and checking CloudWatch log, new incoming CloudWatch log, and checks if this test is available. So this test log is available. So to have it a bit more simple, we see here Chest acting, calling the target logging the test ID, and Chest waits for the whole time expecting the test ID. This is misusing a CloudWatch a bit, but it's a pretty simple and straightforward way to see, hey, is my target actually getting the event? And if it gets the event, is it logging? And then everything is good. So this integration is working. Then for the last point, I have a huge bullet point list of like things I would do. I just go through them very quick. So the metrics in EventBridge are not that great in terms of non-technical, so business metrics. I would always create a rule log all group. That means every event will once be logged to one log group, so you can create CloudWatch metrics and dashboards from your logs. Always use a log formatter, so always use a JSON log formatter to actually understand and correlate your logs and analyze them. Share your events. Doesn't matter which technology you have, you can always share your package in some way, so do that. Mock your failures. So even if you have archive and replay in place, idempotency, error and retry, put a throw new error in there and understand if your whole logic actually works out. Because if you don't do this and you will have an incident, you will have no idea. Then use max concurrency, especially if like other external consumers are working with your AWS account. That makes sense. Use as many alerts as needed and as few as possible, because alert fatigueness is really a thing. So understand which alerts you need, and especially think about composite alerts. And then, get started with it. And I think one thing, the last part is very important, that think about full events versus notification events. So full events is where you have all of the data in there. Notification events, you typically only have some IDs in there. And this always comes down to where is it more expensive for your business to make the actually database request. And typically it is more expensive on the API side because the user needs to wait longer. So try to do that on the consumer side. That's it. I have some resources, so I share all of these slides, so there you can see the resources then in there. I would love to have some feedback. I have a feedback form here on my own page. And that's it. Thank you so much. Paul, you can chime in again.
Hey, everybody. I'm back right here. All right. Yeah. Thank you, Sandro, for all of that. That was a whirlwind for sure. I was trying to keep up. And if you are in chat, be sure to drop some questions. We'll leave the room open for another few minutes. Just looking through. We got,
Daryl was there, nice.
From Canada, and Buff Tomato. I just like this username, Buff Tomato. If you're still watching, it's a wonderful username. And then Eduardo really took something away from your talk right now. He said that the way you use Dynamo for dedupes was very clever. He even said that he had the same problems and he used a different strategy, but he thinks that the way that you've shown is more simple, more easy to follow along with. So I think that's pretty cool. Let's see.
Yeah,
and
like Eduardo, I said, I would definitely check out. I just share the link here. There it is. Join the chat. Oh, I haven't. Okay, I need to send it to you in the private chat. I'm not connected here, but I definitely would check out Power Tools idempotency and just use their library. You just need to create a DynamoDB, give it some permissions, and that's it, because that's really, really cool. Yeah, exactly. That's the link, because that's really nice to use.
Can you tell me a bit about what the Power Tools are and how you use them?
Sure. I haven't. I should have an own slide about that as well. So Power Tools is one library I use a lot, like except with MIDI. I think that's the second one, because Power Tools just gives you, I would say, best practices, how to work with Lambda functions and how to work in general with AWS, but I use it mainly for Lambda functions, for having a structured logger, for example. I always talk about logging and having these JSON logs. So Power Tools gives you a logger for that. They give you idempotency. So they give you reusable things that you can use from really, really smart developers. And also, for example, the whole validation part I talked about, they do on Python that already exists, because there's Power Tools for each programming language kind of. For Python, it already exists. And for TypeScript, there's already, I think, a beta out there to have like a validator and to understand to not do the whole validation I just showed you yourself, but to use them like from smart developers and they just give it to you.
Yeah, I'm a very lazy developer. I try to wait for the folks to build the tools around me, and then eventually I'm able to use them and understand them. One thing that I wanted to ask you about was the cloud events. You mentioned cloudevents.io, and it's something that I've only had on the back of my mind for many, many years. I mean, the CNCF has tried to have some kind of a cloud event standard for a very long time now, but you seem to have. Are you able to utilize it? Tell me about how cloud events has helped for you.
So I typically work in startup projects, so like smaller to startup to scale up projects. So I wouldn't say I haven't used them because we just never had the need for them. We often,
I see.
if you're such a small development team where basically you create the producer and the consumer at the same time, often doesn't make sense in my perspective. But in general, like if you're a huge corporation, if you're an enterprise, like I said, you have probably tons of AWS accounts. You have external AWS accounts. You send something to consumers, like an Amazon reseller, repricer. If you create something like that and you send something to somebody else, then I would go with cloud events. So every time you have some external thing, an external party involved, then I would go with cloud events.
Gotcha. Yeah, I remember when EventBridge really became its own product, and their main
before it was CloudWatch.
before it was CloudWatch events, right? They were able to make a living log turn into a message bus, which is pretty funny. But when EventBridge was first out, a lot of the major like marketing messaging from AWS was all about all the third-party SaaS integrations that they had for EventBridge, So for all the folks that are like living inside of Salesforce or IBM business tooling, they had a connector for you to be able to send events onto EventBridge, right?
That's quite cool.
Yeah, I really enjoyed kind of seeing how you took the architecture apart and made it very discrete chunks, and how that lends to your points about observability and retrying, because you're just firing these things all over the place and it is very distributed. So you do need to be conscious of where all this stuff is spraying around. Did you ever get any experience with using other message technologies like Kafka or RabbitMQ or anything else like that to compare with, EventBridge and SQS and all that?
So RabbitMQ and SQS, I've used Redis queues. I think Bull queue something back then, and RabbitMQ. These are all like good products by themselves. The main part about SQS is that you don't need to. It's a managed infrastructure. So there's like the typical serverless thing. You don't need to update something. You don't need to host it. You don't need to scale your service. So your Redis MQ cannot die basically, or SQS cannot die. But for EventBridge, I haven't used so many. Like in my bachelor thesis, I did work at a huge auto manufacturer, car manufacturer, and there we used Kafka back then. So I did consume lots of events there. But there was an enterprise. I simply had a consumer got events, so I can't do it in detail, can't compare it in detail. I just know if you compare EventBridge with Kafka, or if you connect those two, I saw some talks about that from another AWS community builder. Daniele, he talks about that a lot. Then you have quite some interesting parts to take out, like your message sizes are different in Kafka than in EventBridge. I think Kafka is larger and EventBridge is smaller. So you need to, depending on which direction it goes, need to split the messages and combine it somehow again. And there are lots of things to think about.
Yeah. I wanted to mention that because at the enterprise scale, depending on the folks that are listening, if you're just starting out and you're doing a lot of startup stuff, like Sandro mentioned, it's great to use the native architectures from AWS. So you're able to have these kinds of services that are scaling on their own, and all you do is kind of include them as a library in your application code, which if you're new to serverless, I think it's a pretty eye-opening thing compared to having to provision a bunch of clusters and specify some compute so that you can send these messages around within your systems. Awesome. Let's see. If anybody else has any questions, feel free to drop them in the chat. We got a few more minutes remaining, but Sandro, I have a really big question for you.
Okay.
Is that moss behind you real? Like, is it alive? Like, can you touch it?
No, I think I can touch it. Yeah.
Is it a painting?
No, it's like a guy, like fellow developer in the startup, actually, also community builder, Yannick Wempe. His brother is doing these kind of things. I can share a link if you want, and you can buy it on Etsy.
He's so cool, like a
cool.
living moss-scape, I guess. Is it moss?
Yeah, it is moss. So I think it is. Yeah. I'm not sure if it's living or not. I don't think it's living, to be honest.
Oh, I don't know. The whole time I was slightly distracted. I wanted to touch it.
Yeah, that's why I did the background here.
All right, let's give a shout out to let's give a shout out to the Etsy probably store. Yeah. Support artisans. Love it.
Do you have a GitHub project showing the chest integration? Yeah, to be honest, I started one and I couldn't get it to finish because I'm bad with these things. I wanted to have the blogging platform, and I know how to have like the whole blogging platform. So I started with a tip-top editor, blogs, caching, and then was a bit stupid, so I couldn't finish it. I will deliver this one also with like the chest integration, probably vtest integration, because I would now use vtest. But yeah, I don't have it at the moment. I'm sorry, but I actually stole this idea, so I have it in the resources. How is the guy called? Paul Swale. He's also an amazing guy for like serverless testing. And let me just share that in a sec. Serverless first, it's called, and he had all of these ideas. So I called this. I basically, got all of these ideas from him, and especially about this test. And he and Jan Choi, of course, are doing lots of stuff about serverless testing. So I would check them out.
Yeah, testing is to me, it's like one of the more bespoke areas of development, especially for cloud integration. I think there's n+1 number of opinions on how to do it. So yeah, it's great. Definitely check out this link, Serverless first, and then also, if you're not already, join the Believe in Serverless Discord. If you go to Believe in Serverless, if you just Google search Believe in Serverless, it'll come right up, and you can join the Discord, chat with us, chat with Sandro. I think you're in the Discord too.
I'm also in there.
And then again, let me give another final shout out. Coming up May 9th, a week from now, same time, 1 p.m. EST. We're going to have Joan Zachariah Noel talk about observability in EDA, which Sandro kind of alluded to a little bit. And then on May 16th, we're going to have Alan Helton presenting how to push messages and the limits with Memento. And before we sign off, let's see, any other questions?
So Jones and Alan are definitely pros on that topic. I think Jones talks a bit about, probably he works at New Relic, I think now, so probably puts in New Relic, and then Alan, the boss of Believe in Serverless himself, knows a lot about Memento and using that. So I love Memento as well. That's definitely cool videos to jump in.
Definitely. And then I don't know, let me see. I'll bring is it the slide with your link back up? Final. Yeah. All right. Good. Grab this slide. Let me hide this. All right, folks, this is it. The last couple of minutes here, I'm going to throw this slide up and then say, this one. Hey. All right. So Sandro, where can people find you, follow up with you, anything on Twitter or whatever?
Mainly on Twitter. I think my Twitter, my name is too long. So Sandro, Sandro_vol, VOL is my Twitter handle. I'm mainly active on Twitter and LinkedIn, or you can also shoot me an email. Like the QR code goes to my website, to my portfolio page. So there's all of my contact information in there. If you want to discuss more about EDA, happy to do that. And yeah.
Perfect. Awesome. Well, thanks everybody for joining. Again, if you have missed this live, then we're going to have a playlist on our YouTube channel, Serverless Guru, for all of the recordings for the hackathon. Again, still plenty of time to sign up and create a project where you can win some cash money. And with that, that's it. Thanks again so much, Sandro, for coming. Thanks everybody for watching. And that is our webinar today. Cheers.
Thanks
Peace.
a lot as well.
We all love
See ya.
serverless.